Hello there. Logistic regression is one of my favorites, and one of the reasons why it is my favorite is the mathematics involved in it. If you have forgotten your high school level mathematics, then it might be a little difficult for you to understand this. So, I will first take you to the basic mathematics you need to understand logistic regression. Don't worry, I'm not going to take much time. I will only explain what is must for you to understand logistic regression. So let's begin. This one all of us understand. 10 to the power of 2 is equal to 100. It is very difficult to forget this part. So I hope all of us understand this and it does not need any more explanation. And if I say log of 100 to the base 10, that means I am saying what power of the 10 will make 100. And the answer of course is 2, as we have seen here, right? And in such case of log where the base is 10 is called common logarithm. What if I just write log of 100? I don't write base 10. Then what happens? In such cases, the base is assumed to be number 2.718, that is E. And such kind of logarithm is called natural logarithm, and it is also written as ln 100. That's it. That is the basic mathematics I was talking about. Now that we are on same page, let's move on to understanding logistic regression. Before we jump on to logistic regression, let's take a step back and let's understand what did we do in linear regression. In linear regression, we saw this formula y equal to b0 plus b1 bn xn, right? And we understand that the right side of this equation is continuous number. The x1, x2, x3 and beyond, these are all continuous numbers, and the result of this whole equation along with coefficient is a continuous number. And the outcome will also be a continuous number. You have worked on the cases of predicting fuel efficiency wherein there were independent variables like which were various features of the car, and you came up with the predicted fuel efficiency which was a continuous number. So input continuous number, output continuous number. Let's come to logistic regression. Logistic regression, even though the name says regression, it's actually a classification algorithm. And by classification I mean the outcome is not a continuous number. So let's begin. On the right side it is same. It is still same continuous number. So outcome of this side will be a continuous number. But on the left side, because it's a classification technique, the outcome has to be a binary outcome in case of logistic regression. So binary outcome means values like yes, no, right, wrong, 0, 1. So that kind of outcome. The complexity here is how do you get a binary outcome with the continuous numbers. And that's where the whole fun behind mathematics start. In case of logistic regression, y is replaced with something like this, log of p by 1 minus p, and this one here, this is probability. P means probability, and this whole thing p by 1 minus p is called odd of outcome. So odd. So and the log of this value, remember there is no base to the 10, so this is a natural log. Yes, so this one is a natural log, and so the formula is changed. Now y is replaced with log of p by 1 by p. So that is the formula here. That means log of p by 1 by p, where p is a probability, is equal to y. And if I further expand it, then I come up with this formula that p probability is equal to 1 by 1 plus e raised to minus y. So now this is the very interesting part. Why did I do all this? Because in this formula, no matter which value of y I put, I will always get a probability value, and probability value will always be between 0 and 1. So that means I can still get outcome of this as a continuous number, which will be my y, but the moment I put that y in this equation, I will get the probability value, which will be between 0 and 1. You don't believe me? Okay, let's do this. I put several y values here in this formula, and this was my outcome. This was my p value. You can experiment with more y values, and this was the graph. So now I have a graph of probability values ranging from 0 to 1. Right, these are my probability values and these are y values. So probability value is 0 to 1, right? My graph is looking like this. And then I can follow a simple formula that if my probability value is less than 0.5, I will say no, and more than 0.5, I will say yes. Yes, and right here, I changed my outcome from continuous number to binary outcome, yes and no. And that is why I like logistic regression. The basic mathematics has made a continuous number outcome to a binary outcome. So welcome to the logistic regression. I will see you in next lecture.